Let's go. So 7.2, constructing box plots. When you're constructing a box plot, there are 5 key points that you must have. 1, it's the minimum. Minimums, usually you're meant to put a dot at the end. Okay, so a dot to represent a minimum. Then your next one is the lower quartile, Q1. We use a vertical line to represent where it is on the x-axis. Now I noticed in the quiz some students were drawing the box plot on the axis. Don't do that. You lose marks on that. It has to be above the x-axis because then you can draw multiple box plots. Okay, but you use the scale to tell you where Q1, Q2, Q3 is. So Q1 is the start of the box. Q3 is the end of the box. And then finally you've got your median, which depending on where it sits, that gives you the center of the box. Now the median, when you're interpreting it, if it's right at the center, that's nice. It's a symmetrical median. If the median is left or right, we then say it's a skewed median. You know, it's sort of leaning towards one end or the other. Okay, but it doesn't mean the distribution is not symmetrical. How do you know if it's symmetrical?
If it's skewed, then why would it not be like uneven?
It could mean that there seems to be a lot of data in one specific number, but overall the rest is still 25% one end, 25% on the other, and maybe slightly a bit more on one end. So we say it's skewed median, but not necessarily a skewed distribution. So as long as it's relatively, so we call that reasonably symmetrical is what we'd say. Yeah. No, that's good. So that's a good analysis. So what you normally use to determine if it's symmetrical, you look at the whiskers. The whiskers overall, are they roughly equal? Okay, and sometimes you can look at percentages, you can look at the values. If it's only 1 unit off, that's not that bad. Okay, they're slightly the same. So we can say it's symmetrical or reasonably symmetrical. Okay, so and then don't forget the last bit, maximum with a dot. So you need your 5 number summary. You got minimum, lower quartile, median, upper quartile, and then your maximum. That's called a 5 number summary. For year 11s and 12s, when they ask 25% of the data are above what value, okay, so we know that they're split up into quarters. Each one's 25%. But since you're saying 25% is above a certain number, what is this really asking? Above what value is 25%? Q3. Q3, that's your 25%, but it's above a certain value. So towards the right, usually that means larger. To the left, it means smaller. So depending on the question, they could say above 50% or below 50% or the bottom 25%. You need to be able to interpret that box. At the year 11 level, that's pretty much where you're at. Year 12s, they can play around a bit more. Yeah? Let's do an example so that you can tie in how to draw a box plot and how to calculate the numbers. Here we go. I've given you a box plot in example 1. This box plot summarizes the number of air conditioning units sold at an electrical store. So this represents number of sales. We can clearly see there is maximum of 30 units being sold. So 30 units is maximum. What's the minimum number of units sold here? Can I please have Michael? What do you see? What's the minimum number of units sold? No, that's Q1. What's even further than that? No, 15's over here. 25's over here. What's the minimum? The smallest number you can see? 0. Very good. So right at that tail, that's the minimum. So when we say what's the minimum, what's the smallest unit you can have, it is 0. Very good. So that's your minimum. But what he identified was he identified all the key ones. He said 10, 15, and then 25. He can see lower quartile, which is 10. That's the middle of the bottom half. The middle is at 15. So we call that the median. So that's Q2. And then Q3 is the middle of the upper half, which he said 25. So he said everything except for the smallest value. The smallest value is minimum. And based on the graph, the tail end, look at the tail end, where is the smallest point? And it's at 0. Now we've got our 5 numbers there. We've already got the box plot. Let's answer the questions. B, 50% of days had sales below what number? What would you say? Can I please have, let's go with Amelia. So looking at the data, it says 50% of days had sales. So now this is the number of sales. Below what number? Yeah. 15 is where the middle is. That's 50%. So 50% of the time, 15 number of sales is below. So it's below 15. So 50% of the time, 50% of the days, 15 sales and below are sold. Okay, so I had sales below what number? 15. Okay, so lower than 50% of it is less than 15 sales in that day. Next one, 25% of days had sales above what number? That one we already know. We kind of talked about it just then. Which one is this one? Let's go with Callum. 25, very good. So we're saying 25 is above a certain number. We know from Q3 to the max, that's another 25%. That's why it is above Q3, which is above 25 units. Okay, so 25% of the days, there are 25 units being sold. That's what it's trying to say. Okay, so of all the days, 25% of them, they will sell 25 units. Okay. The last one, if there were 80 days now, so they're telling you how many days there are. If there were 80 days of sales, how many of those days were fewer than 10 sales? Okay, so you got to think about it. So to get 10 sales, look at 10. 10's over here. What percentage is fewer than 10? What's that percentage that I just highlighted, Billy? 25, very good, because that's what Q1 represents. Q1 represents the first quarter is 25%. From Q1 to median is another 25, and then from median to the next one is 25, and then Q3 to the max is another 25. So because they said less than 10, we know it's 25%. But we still haven't answered the question, because they said out of 80 days, we know 25% of them will be fewer than 10 sales. So you need to figure out now, what is 25% of 80 days? How do you type this on the calculator? Let's remind ourselves. 25% is the same as, Billy?
I was going to say, just do 80 divided by 4.
Very good. 80 divided by 4 is one of them. Divided by 4. For those who didn't know, let's say if it was 31% and you weren't sure what number you divide by. So this is the technique. 25% means 25 out of 100, which means on your calculator you type 25 divided by 100. Okay, of means times. So on your calculator you press times 80. Okay, so on your calculator you type 25 divided by 100, which is why you knew it was a quarter, because 25 out of 100 is a quarter, and that's why a quarter times 80, which is what you're doing here. 80 divided by 4 or 80 divided by a quarter times a quarter gives you the same thing as 80 divided by 4. Okay? And that's why you then get 80 divided by 4, which is 20. What does that mean? So you got the number. It's 20. What's this mean?
20 days fewer than 10 sales.
Beautiful. 20 days of the 80 days. Out of those 80 days, there's 20 days that they sold fewer than 10 sales. 20 days, they sold fewer than 10 sales. Okay. All right. And then the last one, flipping over the page. This is just some data, just in case you didn't know how to read a distribution, especially for SACs and interpreting. I'm just going to fill in the points and you can copy it down. So box plots are always drawn to scale. In the SAC, I will be checking if you've been using a ruler to measure it accurately. I know in exercise books, you guys just do dots and just draw them out. But in a SAC, you should be using a ruler. It should be to scale. So this is to scale. Okay. There's two ways of listing your box plot. You can do a scale presented, so you can see the actual numbers. Or you can actually do it this way, where you just label the numbers above it. Traditionally, and for the exams, they usually do it this way. But that's okay to do it this way too. Okay, so there's two ways to present it. You can either do it without a scale, If you do use a scale, you must measure it using a ruler. A box plot neatly divides the data into 4 sections, which we already talked about before, 25, 25, 25, 25. These are the distributions that you can get. So I put the box plots, and then I also put the histograms of what they roughly look like when you say symmetrical or not. So first one, can you see how the whiskers and then the median, they're roughly all centered or they're equal? That's 25, 25, 25, 25. Then you say that's symmetrical. You notice that this one, the whiskers are much longer than the interquartile range. This is implying there's a cluster. It means a lot of people are getting the same scores within a small, narrow region. So this is called a cluster. So we can see the whiskers are much longer than what we expect. So we say clustering of data. This is what it looks like. It means a lot of the data seems to be on one spot, not evenly distributed like the histogram here. Evenly spread. So when you have a box plot where literally the inside of the interquartile range and the whiskers are all roughly the same proportion, that's what that looks like. That's different to symmetrical distribution. Symmetrical distribution changes as we go, okay? Whereas when it's all even, 25, 25, 25, 25, that's what we're saying, that each part is equivalent to each other. Okay, so we say this is evenly spread data. And then your final one, which is generally more obvious, if you notice that one tail end is longer than the other, we call it skewed. But your language, you got to be careful. It's a bit counterintuitive here. When it looks like this, we say that is skewed. Now the question is it skewed positive or skewed negative? So negatively skewed or positively skewed? Yeah, and that's the most common response. That's the intuitive one. The answer is actually positive. And I know it sounds weird, but what they're trying to say is this skew, so where are you pulling it? You're pulling it on the right-hand side. So we say this is a positive skew. Versus the other way, if they did it this way. If your data looks like that, where am I pulling, skewing it? I'm skewing on the left. So this is called negatively skewed. So this is probably mainly for year 12s at the end of year. If you describe this distribution, make sure that's negatively skewed or left skewed, and this one's right skewed. Okay, skewed means the changes, the pulling. And that's pretty much most of what you need to know for 7.2. But for those who are starting scratch, especially 11s, if you haven't practiced, versus 12s are usually pretty good at this. This is now, what if you have data that isn't in the form that you're used to? Can you still find smallest number, median, maximum, minimum? Now for 11s, this is something I would put on a SAC to make sure that you can also read the 5-number summary. Okay, so let's see if you guys can do this. Let's do it again. 5-number summary, you need minimum, you need a median, you need a maximum, and then Q1, Q3. Minimum and maximum is easy to read, so let's look at this stem and leaf plot. Looks like 5, 6 could represent 56. Is that right? Does it say 56? There's no legend. It's out of 100. Yeah, so it must be 56. All right. We got 56, 62, 65, 70, 74, 76, 81, 83, and 98. So what's the minimum? What's the minimum number that we have here? Can I please have, let's go with Ishara. What's the smallest number in the stem and leaf plot that you can see? 56, very good. That's the smallest number, so we're going to write in 56. Okay. Now, for those of you who find it hard to read from a stem and leaf plot, you can actually write the numbers out. You can write out 56, 62, 65, 70, 74, 76, 81, 83, and 98. I personally don't normally do that. I actually just look at stem and leaf plot. Here we go. How many numbers do we have? Actually, so maximum is 98, clearly. How many numbers do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's nice about a stem and leaf plot? It's all ordered for you. So the data is from smallest to largest already. You don't have to reorganize that. Now, the next one you should find is the median, because you need to know where the middle is. Now, you've got 9 numbers. What's the rule again to find the middle? Good. The rule, if you've forgotten it, it was n plus 1 divided by 2. N is the number of numbers. I've got 9 numbers, so 9 plus 1 divided by 2 is 10 divided by 2 is 5. What does 5 mean? That tells you the position where the middle is. So here, the position for the middle is at the 5th position. This is the 5th position, so the middle must be 74. That's the middle. Now, for some students, you don't realize, and this is one of the ways I teach to my students, I say, if you know the middle, draw a line through it. Cut it out. So 74 is cut out now. So what's the bottom half? It's these 4. 1, 2, 3, 4. What's the upper half? These 4. 1, 2, 3, 4. This is the upper half. That's the lower half. Now that you know the middle is 74, you need to find Q1, which is the middle of the lower half. I've got 4 numbers, 56, 62, 65, 70. Yep. Yeah, that's fine. Yeah. I'm only doing it for those who, when the numbers get a lot, sometimes that rule is just easier. Yeah. So yes, now that we've got these 4, the middle of 4 numbers, again, you can use the rule. 4 plus 1 is 5. 5 divided by 2 is 2.5. 2.5 tells you it's in the middle of 2 and 3. Thanks, boys. So 2.5, when you use the rule, it says 2.5. It tells you it's the middle of 2 and 3, which really is the middle of 62 and 65. Now, how do you find the middle of 62 and 65 again? What's the technique? Some of you can count with their fingers, but some numbers may not be obvious. So how would you normally do it by technique? What do you have to do? Pav, do you know? Not sure. Who knows? Jack? Good. You sum them together so you get a total amount and you share it equally. That's how you find the middle. Yeah, it's like if I had $62, Billy has $65, and we want to share it equally, how do we find that middle? Let's take our money together. So 62 plus 65. Now that we've got total money, we'll split in half. That's how you get the middle. Yeah, if you have 2 numbers. So here, how do you find the middle of 62 and 65? We then do 62 plus 65, collect all the money together, and then split it in half. That will give you the exact middle between them. 62 plus 65 is 127. 127 divided by 2 is what? Oh, that's 63.5. Okay, so now I know the middle, which I'm going to draw a line here, that's 63.5. And arguably, I think that students tend to make a mistake on. Okay, so just finding that middle of the lower half, that's where students can make a mistake. Just knowing those. So make sure to copy those 2 notes so that if you didn't know, that's how you do them. Q3 is the same thing. Q3 is the middle of the upper half. And again, I got 4 numbers, so it must be in the 2.5 position. So between 7 and 8. Here we go. Between 7 and 8 is 81 and 83. That one's easier. Middle of 81 and 83 is 82. So that was easier to do. Okay, so some numbers are easier and then some numbers aren't. Okay, so between 81 and 83, you can see it's 82. Or you could have used that technique that Jack said. That would also work too. Once you got your 5-number summary, here's just saying calculate IQR and outliers. Let's see if you guys remember the rules. Usually they give you the rules anyway. So for 12s, you will have the rules in the back of your sheet. IQR, how do you work out IQR again? Good, Q3 minus Q1. And how do you find outliers? Good, so you got upper fence and lower fence. Callum, what's the formula for upper fence?
It is Q3 plus 1.5 times the IQR.
Good. So for those who've forgotten, upper fence, Q3 plus 1.5 times IQR. Lower fence, Q1 take away 1.5 times IQR. That's how you work out any outliers if possible. I'm going to pause the video there, but you should be able to now work out IQR, upper fence, check if there's any outliers, and then sketch it on this graph here. If there are outliers, what do you use to demonstrate it's an outlier on a box plot? Anyone know? Yeah. You do a little dot or you do a cross. Okay, so it'll look something like this. You do minimum, Q1, Q2, Q3 as an example. maximum, and then if there is an outlier, use a cross or a little dot on that side. But we usually do a cross to show it's an outlier. Okay. All right, team, I'm going to stop there. That's it for today. I will be using this session just to catch up with some students about their work in terms of what we just covered, because that was pretty much what the quiz was about. Okay. All right, I'm going to stop the video.